Hello, my name is Ziv and I'm a NFV QE team member. In today's demo, I'm going to show you how to use our Ansible NFV plugin framework for executing performance. But first, I'd like to point you to a demo that I have created some time ago. It will explain in details and provide you with examples on how to create resources for the performance use cases. And there's actually a lot of them. Such as networks, subnets, ports, router, flavors, aggregation groups, keys, images. And by the way, images, following image will have pre-installed TRex, TestPMD, binary search applications, and necessary tuning for the performance. And lastly, it will deploy for us the performance instances. So, assuming that you are familiar with the following demo, I will continue to the performance execution with our Ansible plugin. I will also explain some of the parameters that we're using day-to-day in our performance CI. I'll execute manual performance test with the binary search script. And lastly, I'll show you how we manage performance with Jenkins automation. And I'll explain how the binary search script is working. My working environment is based on the following diagram. As you can see, I'm using top-of-the-rack switch and two computes. Compute 0 is hosting TRex VM, which is a traffic generator, and compute 1 is hosting our two devices under test. We can see that in NUMA node 0, there is a SR-IOV DUT VM, and in NUMA node 1, there is a DPDK DUT VM. It is important to notice that my environment, such as hypervisors, instances, has been completely tuned in advance. It is a mandatory NFV requirement. It is simply because otherwise you might have severe degradation, even get to the point where there is no traffic at all. And this is a complicated issue by itself, so I'm not going to waste your time on it in the following demo. So I'm simply going to assume here that you're perfectly familiar with the following subject. But in any case, there are plenty of information about it in our NFV documentation. Here I'm zooming in specifically on our DUT Compute 1. This is our current PMD layout. As you can see, I'm using just two PMDs core. Core ID number 2 and core ID number 3. Basically, one PMD per each NUMA. So PMD number 2 from NUMA node 0 will be responsible for the SSH access to our two VMs. And PMD number 3 from NUMA node 1 will be responsible for the DPDK traffic. So in the following scenario, let's say with OVS 2.11, we can get around 1.45 million packets per second. So in total, around 2.9 million packets per second, which is pretty good performance for a zero packet loss with just one PMD. By the way, in the near future, we're going to add additional PMDs to our performance test. So it will allow us to get even higher throughput with the DPDK scenario. But currently, the problem with additional PMDs is that you end up initially in a chaos where the DPDK ports with other ports is not properly balanced, and you need to manually do a PMD isolation affinity, which is of course possible, but it's a little bit complicated and time-consuming, and for sure not so simple to implement it in automation. So there is actually a solution for that. Our development team is working to provide what is called PMD RxQ rebalance, which basically stands for automatic assignment of port RxQ to PMD threads. It is currently experimental and we're not using it yet, but it's just a heads up for the future. All right, so enough talking. Let me begin the demo itself. And this is the command that I'm going to execute for the DPDK scenario, and I'll explain some of the main parameters that I'm going to use. So the cloud resources external means that we're using already existed environment for the performance. DUT compute and EMC insert, it means that I need to specify what is the name of my DUT compute, and it will allow me to apply some features to it. And in our current case, it is a EMC of 100. There is additional parameters for the DUT compute, so please read more about them in our documentation. The link, by the way, to the documentation is pasted over here, so I can quickly show you what other options there are. So you can see we're using here MC. There is also some parameters for tuning, such as default emulator pin in case of ROS 10. What else? We have here, it's a binary pair flock. It means that you can choose where in your undercloud environment you would like to save the binary search output log. We have also DUT group DPDK and DUT type. It means that I'm providing to Ansible the information about the existing VM, so it can gather the necessary information about it, such as its IPs, floating IP, port, MAC addresses. Again, please read about it in details in our documentation. TestPMD L course is a configuration for the TestPMD on our DPDK DUT instance. I'm just saying here to Ansible which L course and test course to configure on the application. Let me show you my compute. This is my compute where is the DPDK instance is running. So this is the CPU list of it. And this is the CPU, virtual CPU list of my DPDK instance. We can see I have 8 ports, and I have asks to configure 3, 4, and 5. So 3 stands for physical CPU 15. We can see that 15 is actually sitting, is from the socket 1, so I know that my instance has been properly booted on the NUMA Node 1, exactly where I want it. But anyhow, I'm in L core, I must use a physical CPU without the hyper-threaded core. And I also configured 4 and 5, which stand for 929. In our case, it's a hyper-threaded. It will handle the traffic, DPDK traffic. The reason I have showing it here because just pay attention to the command and paste with the correct course, because for sure in your environment there will be different amount of the CPUs and a number of them, so just pay attention to that. Okay, and lastly, we have TRex rate of 2, means that it will start the binary search script with a rate of 2 million packets per second. As we're using here DPDK performance scenario, there is no reason to set it higher, because maximum that we can be able to squeeze, it will be around 1.32 or 1.45. So there isn't a reason to put higher than 2. By the way, in case of SR-IOV, we can see that I'm using here 14 because this is the maximum I can get with one port. In SR-IOV is around 13.9, where it is absolutely tuned. Okay, so let me start the performance with Ansible. So I'm using here exactly the same command that I have just shown you with all of the parameters. Please be patient because it will take maybe 2 to 5 minutes to actually start the performance. I'll explain a little bit what is happening in the background of it. After the Ansible has gathered all the necessary information about the TRex and DPDK DUT, it will open Tmax sessions on each one of them and start the application with the relevant parameter for the performance. So we're just waiting that it will finish gathering the information, and it will open the Tmax sessions and begin the performance. Right now it's running TestPMD in the touched Tmax session. It's just making sure that TestPMD application has been successfully opened and it's ready to accept traffic. Now it's creating a Tmax session on the TRex and starting TRex in a server mode, and it has started a binary sort script. So we can launch, we can open a session to the TRex console in a read mode and see how the traffic is coming. So we can see that traffic's coming in and comes out, and it has started with a rate of 2 million packets per second. Okay, and I will show you some options that we have here. So as we're using the binary sort script, it's actually using 2 streams per each port. So it's doing throughput and also doing a latency. So we can also see the latency and the jitter as well. So as it's a binary search flow, it will take around 10 minutes or so to stabilize it. And so we're not going to wait until its end. So I will stop it now, and we will continue to the manual execution. As I previously said, it's opening a Tmax sessions, and as we have just canceled the Ansible performance execution forcefully, we needed to kill the Tmax session on the TRex and the TVM. Otherwise, we will not able to start TRex in server mode and TestPMD application correctly. So I'm now going to show you how can we run the same performance but manually without Ansible. So for that, we need to open 3 sessions to TRex and 1 session to the DPDK DUT instance. I have already created those sessions, so it's just a matter of starting the applications. So in first session of TRex, I will start the TRex in a server mode. And in the second session, I will open a TRex console in a read mode, which is still actually is running, so there is no need for me to exit and relaunch it again. And in TestPMD, I will start a TestPMD application. By the way, you can see that I'm using exactly the same configuration that I have passed to the Ansible. So TestPMD is ready to accept traffic. So in the third session of TRex, I will launch binary search script. The parameters that I'm using here is, again, the rate of 2. The frame size of packet will be 64. And the maximum loss packets that I'm willing to accept is absolutely 0. So as we can see from the TRex console, the performance is running, but we did it in a manual way. Exactly the same options we have, like streams, like latency we can see. For sure now we have jitter because actually my environment can only get to send back around 1.32 million packets per second. That's why we have latency and jitter. So it will take binary search to stabilize around 10 minutes, and then it will be fine. So I will stop. And by the way, to show you that we have traffic on the TestPMD as well, we sending now around 1 million packets per second. So we can see that exactly the same amount we getting and almost the same we're sending back. So I will stop the binary search script now, and I would like to show you some other options that it has. It actually has many of them. We're not using most of them. We're just using the general one. We're using flow as a binary, as a bidirectional flow, and tolerance of 0 packet loss. There are many options here, right? So we can say that instead of running in a binary search, we can run it with one shot. We can just set it to run on a specific speed for as long as we need. We can set it validation runtime. So please read about it. By the way, I have pasted documentation on the script. The script has been created by Andrew from the Rail performance team. So credits goes to him, and please read it over there, the other options of the application. What else I can share with you? So we can, let me show you the log, the output log of the binary search, and I'll try to explain it, how to read it. So I will take logs from one of our jobs that has finished lately. We see that in addition to other general stages that we have in our environment, I have also created 4 additional stages for the performance, which is a resource creator, and then it's a run performance. The performance is not running simultaneously; it's run in a serial mode. So first begin with DPDK, then it start SR-IOV, and then it's delete the resources that it has created. So the logs can be seen here. We have 2 logs here, one for DPDK and one for SR-IOV. Let's concentrate in DPDK. So as I said, with binary search script, there are many options, and there are default parameters for that. And everything is changeable. So, it's starting with a trial mode, which called search. So it starts in a rate of 2 million packets per second, and it's running for 30 seconds. So basically, whole point of the binary sort script is to basically trying to achieve the maximum throughput that it can get with 0 packet loss. So this is what it's trying to do. So first we started with 2 million packets per second, and I was able to achieve 2 million packets per second, but I have a huge packet loss. So it's starting again trial mode of search with, but now with 1 million packets per second. And for sure we can reach that, and we also reach a 0 packet loss. So now it's trying to a little bit higher with 1.5 million packets per second. So for sure we can reach it, but we also got 0 packet loss. So we got packet loss. So now it's trying a bit lower, 1.25. Again, we can reach it, but now with 0 packet loss. So now it's trying a little bit higher, 1.37. And we can achieve that, but we also have many packet loss. So now it's trying a bit lower again, 1.31 for 30 seconds. It can reach that number and also 0 packet loss. So now trying a little bit higher, 1.34. And it can reach that number, but with some packet loss. So now trying again with 1.32. And it can get that number, but still with some packet loss. 1.320, we can reach that number and actually get a 0 packet loss. So it's trying its luck and a little bit higher, 1.324. We can reach that number, but again, we have some packet loss. So now we trying a little bit lower, 1.32. And we achieving this number, but with 0 packet loss. So, by the way, sorry for it being so long, but I'm trying to explain how to read this log correctly. So the last stage for it will be a trial mode final validation. The final validation will also, by default, will be run for 30 minutes. What it means that as soon as it find the number that it can get for 0 packet loss, in our case, it's 1.32 million packets per second, it will run for final validation, and it will finish with that. So in our case, it ran for 30 seconds, and it found out it has some packet loss. So what it's trying to do is trying to run again trial mode and find the correct number that it can run for a 0 packet loss. So trying again with 1.32, it got 0 packet loss, and it's running again final validation for 30 seconds, and it's finishing, and we can see that we have achieved 1.32 million packets per second for 0 packet loss. So this is our throughput that we can get when everything is tuned and with one when everything is tuned, and some other parameters that we see here is that validation runtime here is default is for 30 seconds. So we can set while we executing the binary sort script to set it for 1 hour, 2 hours, but we need to. But as you can see from the output log, it means that if you set it for 1 hour, let's say, validation runtime, it means that it finds the number that it can get for the 0 packet loss and will run this number for 1 hour. So if during this hour there will be even 1 packet loss, it will start all over again. So by the end, you can end up with running performance for 2 hours or 3 hours. So please take it in the account. Basically, I think that's it for today, for this demo. I hope you have found it interesting for you. And for sure, if you have any questions that you would like to ask, feel free to contact us on the IRC channel. And thank you and have a great day.